us a different direction. We're going to start off chapter 6 talking about vectors. We talk about parametric equations. We talk about polar coordinates. And I feel like there's some other topic I'm forgetting, but, we talk about several different trig-related items. And so today's topic is vectors. So by definition, a vector is a directed line segment in the coordinate plane written as, and that looks like ray PQ, where point P is the ordered pair x1, y1, and is the initial point, and Q, written as x2, y2, and it is the terminal point. Okay, so on paper, it looks a lot like a ray. Officially, it is a directed line segment. Okay, so it has a line segment that has direction to it. Now, important to notice that P is represented as the initial point. So the point away from the arrow is your initial point. It is denoted as x1 and y1. And then Q, the one by the arrow, is your terminal point. So it's important to recognize which one is your initial point and which one is your terminal point. Now, we're going to go through kind of some vocabulary, some information about vectors, and then we'll go through some examples. So, first of all, we're going to talk about something called component form. Given your initial and terminal points of the vector PQ, the component form of the vector is written as V equals V1, V2. So this is your component form of a vector. Now, that would come from, if you know your initial and your terminal points, V1 would be your x coordinates subtracted. So x2 minus x1, so as in the x value from your terminal point minus the x value from your initial value. V2 is your y values, and it's y2 minus y1, so y2 from your terminal point minus y1 from your initial point. Notice, when we write vectors, and I haven't thought to look up the vocabulary, it's not traditional parentheses, is it? Okay? It is, I don't know, they look like angled parentheses in a way, right? Or parentheses with a point in them. So, do note, that is what we use for vector notation. It is different than parentheses, so you should make the effort to put this instead of parentheses. Do be careful, they can kind of turn into looking like sevens and whatnot. Just saying, it's real easy to get sloppy with them. But that is component form, V1, V2. HMT, or head minus tail rule, okay, a good way just to remember how do we find component form. And I used the vocabulary here a moment ago that you were doing the terminal point minus the initial point. Heads minus tails. As in, the head of the vector, the arrow, minus the tail of the vector, the part away from the arrow. So heads minus tails is a good way to think about finding the component form. And then the component form of the vector is also sometimes called the position vector. So you may be asked to find the component form, which is usually what it is, or maybe the position vector. Okay. We're also going to talk about the magnitude or the length of a vector. And you will notice notation for the magnitude or length of a vector, it looks like absolute value bars. And it is absolute value bars in terms of that's how we read it. The absolute value bars don't do what we traditionally think of absolute value bars doing. I know traditionally we think absolute value bars just make the value inside of it positive. And that's not exactly what happens here. But that is the notation we use. So the magnitude or length of a vector is determined by finding the distance between the initial and terminal points. And we have some formulas used. This one over here should look familiar. Square root of x2 minus x1 squared plus y2 minus y1 squared. You learned that back in algebras, middle school math, the distance between 2 points. Okay. The shortened version is to do the square root of v1 squared plus v2 squared, and that would be if you already have your vector in component form. You can use that. Okay, so either are good ways to find the magnitude or length of a vector. Magnitude or length, absolute value, can also be called absolute value of v. So there's, you can read it that way. So we'll talk about that. We're also going to talk about adding two vectors. And when you add a vector to a vector, you're just adding the like components. So the first component with the first component, second component added to second component. Okay, so it's kind of like the idea of adding x with x, y with y. So that is to add or subtract components. When multiplying when multiplying by a scalar or a constant. So this is when you have a vector and you want to multiply it by just a single number. Okay, so a constant. You're just going to take that single number and distribute it. So you multiply it to both components. Later, I think it's in 6.2, we learned how to multiply a vector times a vector. That's a little different, but this is just if you're multiplying by a single value, how to do that. Okay, so here's a reference page of, or a reference section of, this is how you find the different pieces of information, right? So let's go and look at example 1 and see what we can do. Example 1 asks us to find the component form and the magnitude of vector v, which is pq, where p is the ordered pair -3, 4, and q is the ordered pair -5, 2. So let's start with component form. Okay, we want to find the component form of vector v. Thoughts on how to start? Okay, and how are we going to find v1 and v2?
Y minus the x value. X2 minus x1.
Okay. So in order to find v1, the first component, we're going to do x2 minus x1, right? So is that -3 minus -5 or -5 minus -3? -5 minus -3. And it helps, if it helps, here's my diagram of PQ. So that kind of gives you the idea that P is the initial point, Q is the terminal point, or I threw up the idea of heads minus tails. I don't know, that's easier for me, personally, rather than saying terminal minus initial. Heads minus tails, so that tells me, oh, I'm doing Q minus P. So I do agree. It's going to be -5 minus -3. What about for V2? What am I doing for the second component? Y2 minus Y1, which is going to be 2 minus 4. So clean that up. -5 minus -3 is -2, and 2 minus 4 is -2. This is your component form. Now, keep in mind, in component form, this is V1 and V2. Okay? So that is your component form. Easy stuff. When given the ordered pairs, just take the x's, subtract, take the y's, and subtract. Just watch your order. Order matters. Now, the other thing we're asked to find is magnitude. How do we find magnitude?
V1 squared plus V2 squared minus squared.
Okay. So magnitude is the one where we're doing the absolute value, right? And Angela mentioned the square root of V1 squared plus V2 squared. There's another formula there too, yes? Could you use it if you prefer or didn't have your V's? You can. And I'm just going to show you the connection. I totally agree with Angela here in that I would just go straight to my square root of V1 squared plus V2 squared. But if you didn't realize that, you could go back and use your x's and y's. So you could do the square root of x2 minus x1, so -5 minus -3, quantity squared, plus y2 minus y1 quantity squared, so 2 minus 4 quantity squared. You can go back and use your x's and y's. Okay. However, don't those insides look similar to what we already did? If I clean that up now, I'm doing the square root of, well, negative 5 minus negative 3 is negative 2 squared, plus 2 minus 4 is negative 2 squared. My point is, I have two different forms of the equation written here. They both work. Okay, in this scenario, they both work. Clean it up. Negative 2 squared is 4 plus negative 2 squared is 4, and 4 plus 4 is 8. Well, we're not going to leave our answer square root of 8, are we? What is your non-calculator version of the answer other than square root of 8? 2 square root of 2? As in there's a perfect square of 4 in there, right? 4 times 2 is 8. And so this can become 2 square root of 2. And that, of course, is your magnitude. Okay. Okay. Questions on that section? Okay, let's move on to the next section. The next section gives us two vectors. Suggests that let u equal the vector negative 1, 3, and v equal the vector 4, 7. It asks us to find the component form of the following vectors. Thoughts on what I should do here? What are we going to do? Do u plus v.
You just add them together.
Just add them together. Okay. If you go back up top, it talked about in order to add two vectors, we simply add the components. So you're adding like components. So in this case, let's see, u is negative 1, 3 plus v is 4, 7. Okay. With that in mind, just add the like pieces. If you want a step, not that you guys need a step, we're going to be adding what? Negative 1 adds to 4, and 3 adds with 7. So if you wanted a step of work there, you could. What do we get when we add these? 3, 10. Okay. Gentlemen, be with me, please. B. 3u. What about 3u? What do we do to get 3u? Yeah. 3u means we're doing 3 times vector u, which is negative 1, 3. When it's just a constant out front, it's a distributive. So then you're doing 3 times negative 1 and 3 times 3. Giving me a final answer of negative 3, 9. And final one in this section, 2u plus negative 1v. What do we do with 2u plus negative 1v?
Distribute the 2 to the u and the negative 1 to v, and then add them.
Okay. Typical, I would say, order of operations, if you will. You need to multiply first, so 2 times u, negative 1 times v, and then, yeah, you're just adding like we did. So kind of combining parts A and B. So if I write this out as 2u, so 2 times negative 1, 3, plus negative 1 times v, so negative 1 times 4, 7, When I multiply this first vector u by 2, I get negative 2, 6. When I multiply the second vector by negative 1, I get negative 4, negative 7. And add negative 2 comma 6 plus negative 4, negative 7 is negative 6, 1. Are you being careful with your vector marks? It's very easy to make them sloppy and turn them into numbers. You laugh, but you'll do it. Biggest thing I see is they become 7s. I don't know. Or we're just not used to having them, so we want them to be a number or something, or a letter, and not a mark or a vector mark. Okay, so that's some of the basics. You have that information up top to reference, right? So hold on to it. Make sure you refer to it when you get to the vocabulary you're not sure of. On the back side, we're going to talk about a unit vector. A unit vector is a vector that has a length of a unit. So it has a magnitude or length of 1. Thus, given vector v that is not the 0 vector, the following formula can be used to find a unit vector in the direction of v. And there's two different ways to write the formula here. They're interchangeable. It all comes down to, I'd say, personal preference. Okay, so they tend to use u for unit vector. U doesn't have to represent unit vector, but in a given scenario like this, it will. And if we look right here, so at the first formula, u equals 1 over absolute value of v times v. What's that absolute value of v represent? Absolute value of v is the magnitude, right? So when we go to look at this formula, absolute value of v, that is going to be, you're going to have to find the magnitude. Okay? Either way you look at the formula. The v itself, so this v right here, that just represents the component form. Okay, so the v that is not in the absolute value represents component form. I personally tend to use the first formula. I don't know why, I just do. If you decide setting up that you prefer the second formula, that's fine. Okay, they are equivalent because it's just the idea that 1 over absolute value of v times v is going to equal v over absolute value of v. Okay, so example 3 asks us to do two things. It asks us to find a unit vector in the direction of v equals negative 3, 2. And then after we find that unit vector, we're going to be asked to verify that it has a length of 1. So let's start with finding a unit vector. Well, based off of the formula we just were given, what are we going to need to find in order to find the unit vector? We have to find what? The magnitude, right? It's magnitude times, or 1 over magnitude times component form. Well, we have to find the magnitude. So how do we find magnitude? It's the absolute value of v, which is the square root of, and easiest thing to do is v1 squared plus v2 squared, which, what are my v1 and v2? Yeah, that's going to be the negative 3 and 2. So we're going to have square root of negative 3 squared plus 2 squared. Clean it up. Negative 3 squared is 9. 2 squared is 4. 9 and 4 is 13. So the magnitude is square root of 13. Okay, so that is your magnitude. Now, we were asked to find the unit vector. In order to find the unit vector, we have to know the magnitude and we have to know component form. What do we already have? We have component form, right? This right here, when I said V1, V2, this is component form. So we found magnitude, we were given component form. So U1 over, what is the absolute value of V or another, well, actually let me write the formula first. 1 over absolute value of V times V. Now let me fill it in. 1 over, what is absolute value of V? Square root of 13 times the vector V, which is -3, 2. What do we do with that 1 over square root of 13? You're just going to multiply it in, distribute it in. Okay. If you'd set this up as a fraction, where you had the vector over square root of 13, you just put the square root of 13 with both pieces. I kind of like to distribute it in. What is 1 over the square root of 13 times -3? Yep. -3 over the square root of 13. What is 1 over the square root of 13 times 2? 2 over the square root of 13. Good news, you get to leave it like that. Okay. So that right there is your unit vector. Okay, so that's how you use that unit vector formula. You find the magnitude, you multiply 1 over the magnitude times the component form. The other piece of this problem that we're asked to do is to verify that it has length 1. How am I going to verify that it has length 1? How can I verify this has length of 1? Can I find the length of this vector? Do we have a way to find length? What's another name for length of a vector? Magnitude. Okay. We can find the magnitude or the length of the vector. So I can do the absolute value of V. Except it's not V here, is it? The absolute value of U. Okay? So we can find the absolute value of U. Remember that is the square root of, normally we say V1 plus V2, right? Excuse me. V1 squared plus V2 squared. It's kind of U1 plus U2, square root of U1 plus U2 squared, but the math is not horrible. It looks ugly, but give it a chance. So it's going to be the square root of -3 over square root of 13, quantity squared, plus 2 over the square root of 13, quantity squared. Okay. What is -3 over the square root of 13 quantity squared? Because -3 squared is 9. Square root of 13 squared is going to be 13. So that's going to be 9/13 plus 2 over the square root of 13 quantity squared. Yeah, 2 squared is 4. Square root of 13 squared is 13. What's 9/13 plus 4/13? Yeah, so we have the square root of 13/13 which is indeed the square root of 1. And don't ever stop at the square root of 1. What is the square root of 1? 1. What did we just do? We showed that the length is 1. It asked us to verify that this unit vector we found has a length of 1. Basically, we just kind of verified that we followed the formula correctly. Okay, we used our unit vector formula here. We used it correctly. That is a correct answer. It does have a length of 1. Okay? Yes?
Do they all have a length of 1, or is it going to ask, like, find the length of, like, 4?
If you found the unit vector, then it will have a length of 1 if you've done everything correctly. Is that what you're asking there?
Yeah.
Yeah. No. The only way it's not going to have a length of 1 is if you goofed up a formula somewhere. Like made a mistake in your magnitude or made a mistake in over here somewhere. That's the only way it wouldn't work out. Okay. Okay, so that's a little bit about unit vectors. With this in mind, okay, we've been looking at the basic component form v1, v2. Okay, there are two ways to write this. Okay, where traditional is the v1, v2 component form, like what you saw on the front. We can also write things of what is called a linear combination. And the idea here is it uses these two basic unit vectors. I, which is the unit vector 1, 0. So that would basically be the vector leading out to the ordered pair 1, 0, which would have a length of 1. And then j, which is the unit vector 0, 1. Now, all vectors can be written based on these two vectors. So if you follow this here, okay, like on the front, v is the basic vector with component form a, b. Well, you could take a, b, and you could split it into 2. So if we split it into 2 where it's a, 0 plus 0, b. So that's just taking your a and b and splitting it into 2 vectors. If you basically factor the a out, so, you know, reverse of distributing it, you could have a, 1, a times the vector 1, 0, and b times the vector 0, 1, with the idea that what was listed up here is that I represents 1, 0, and j represents the vector 0, 1. This can be written as a times the vector I plus b times the vector j. And that is what is called a linear combination. Okay, so this right here, component form a, b, is equivalent to saying a times vector I plus b times vector j. Okay, so both are good. We have different reasons we would use different formats, or different places you might see different formats. By using this format, we have a linear-like combination using the vectors I and j. The scalars or constants a and b are considered the horizontal and vertical components of the vector v. Okay, so a being the horizontal component because it's the x component, b being the vertical component because it's the y component. Now, where this stuff will come into play, we're going to talk about the direction angle of a vector. The direction angle of a vector v is the angle theta that the vector makes with the positive side of the x-axis. Using trigonometry, the horizontal component of a vector is a, or it's the absolute value of v times cosine of theta, and the vertical component of the vector is b, or the absolute value of v times sine theta. Now, if you put a little bit together from our last 2 units, what do we know about an ordered pair on the unit circle? It's cosine, sine, right? What are you noticing here? The horizontal component uses a cosine. The vertical component uses a sine. So that's kind of good to note there that horizontal component, absolute value of v times cosine theta. Vertical component, absolute value of v times sine the idea that a vector can be written in a linear combination. So A times I, so absolute value of V cosine theta times I, plus absolute value of V sine theta times J. Some of this comes down to, okay, how do we find our component form? If you're giving the heads and the tails, okay, or the initial point and the terminal point, you can subtract them that way. But we aren't always given that information. So this is, okay, if we know magnitude and we know an angle, this is a different way to work with them, okay? And U here representing the unit vector, it just doesn't have an absolute value of U because the length of the vector would be 1, okay? Tomorrow, when we come in, we will talk about example 4 and finding the components of the vector, and there's a good example. They're going to give us the direction angle and the magnitude, but we need to find the component form. So we're going to talk about that and then work on those a little bit, example 4 and 5, and then we will talk about part 2 tomorrow also, probably just the first example, I think. Okay? So, homework, you could start looking at some of the homework. I don't know. We should also, I would think, have at least a little bit of work time tomorrow. I wouldn't think this would take us the whole time, but I guess, I don't know, it could take longer than what I'm thinking. So, this homework will be due on Wednesday because that homework does represent part 1 and part 2 of it. Okay?